Okay, we are in code.org Unit 3, Games and Animations in the Computer Science Discovery curriculum, and we're on Lesson 22, going over some complex sprite movement. So we figured out how to control our sprites, how to control them with a keyboard, with a mouse, how to make things act differently based on different conditions being met. So at this point, we're just sort of supercharging our tool set and learning more tricks that we can do. So yet again, we are back to the prediction level to start off a lesson. If you've never seen it before, maybe you have a guess, but we have a sprite that is created. There's no animation set, so by looking at it, if you could at least predict that there's going to be a gray box, you win the prize. And there is something called velocity x that we're seeing. It's not just a x, but a velocity x. We click run, and I may have to enter something here. Let's see. So it wants you to predict what you think will happen. So the sprite will move at an increasing speed, which is what will happen. So if we click run, we see a gray box move from left to right. So even if you just got that it was going to move from left to right out of that, you're in good shape. So we're learning about the velocity property that is a little bit different than the sprite.x counter pattern. So we'll kind of investigate it as we go through this lesson. Okay, so let me start over. So right now we have a red car that is just barely trickling along. Now the cool thing about velocity, where it differs from just the sprite.x. Sprite.x just sets an x position in terms of pixels on the grid. Velocity x indicates a direction and a speed. So you can actually set a velocity x outside of the draw loop and it will still give movement throughout the program, because right now, until it is changed, that car has a property set to it to have a velocity of 0.2 pixels per frame. So that's the cool thing about velocity, is it doesn't have to be a counter pattern to start with. It's almost like this whole thing, the initial velocity x is the counter pattern, but it's constantly going to update without having to be in the loop. Now, a lot of times we'll still put it in the loop, and the counter pattern with velocity is what we can use to have increasing or decreasing speeds in certain games to simulate gravity or other types of forces. So what this one wants us to do is change the sprite speed. So add code to make the sprite speed up, or the car speed up. So I'm going to take that initial velocity. So I'm going to say, all right, this is a velocity x. The name of the sprite is car, and it is going to get, and I will do the old way here with the block programming, it's going to get its previous velocity. So that's what that is saying. Hey, take the previous velocity and each frame increase it by, I'm going to do an increase by 0.1. All right, reset and run. And now you can see that car really speeding up. Obviously, the more dramatic your increase, the faster it's going to go. But remember how quickly these frames turn over. So a lot of times with the velocity, you're probably going to be dealing with one or less in terms of a counter pattern to speed things up or slow things down. Alrighty, level 3, on to some skill building. Again, I'll start over fresh. We have got a rock that is falling. We want to simulate gravity. So we want to use velocity with the y property. Remember, y, as we go down, it increases. So we are going to say we want the rock's velocity y to, again, this will be an increase. And it'll be rock dot velocity y. And again, I'll do plus, this time I'll do plus 0.2. So it's twice as much as last time. We run, and you can see the rock start to fall faster the further down it goes. Level 4. All right. There's a car that's going to run in the water. We want to stop it, so use the counter pattern to slow it down. Add code, or you can do that. And then there's a challenge. Can you figure out how to use a conditional with the above counter pattern to get the car to completely stop before the water? So let's just get it to stop before the water as it is. So right now it's got a velocity x of 10, so it's really moving. So we are going to set the car's velocity x. So right now it is moving 10 pixels per frame from left to right. We want to counter that, and as you can see now, this is why you may want to set a velocity outside of the draw loop, and then you can update it to kind of counter it inside the draw loop. So kind of a cool concept. It is going to be now a minus because we want to slow it down, so that'd be car dot velocity x, and I'm going to do 0.5. All right, and that may be too much. Let's see what happens with that. Okay, so that was too much, so let me go down to 0.3. All right, that was still a little bit too much. Let me try 0.2. So you can tell that with these decimals. So 0.2, that gets it almost to the water, so I'm going to try 0.25. Because I want it to get right to the edge of the water. That's pretty good. Okay, so now what I want to do, I don't want it to necessarily back up. So now I can, for that extra challenge, I can do a conditional and say if, and I'm going to do a less than. So if car dot velocity x is less than 0, then I want to set it to 0. So it may back up just a little, but that'll keep it from going too far back to the left. So we run, we stop, and then the car can just stop. And at this point, well, you could really nitpick and try to get it to stop perfectly on the water, but I think I went the wrong way that time. So just being annoying at this point, I know, but there we go. We can stop it right at the edge there for those of you that like to live on the edge. Okay. Okay, so some practice problems. Rising bubble, floating balloon, and slow down reverse. So let's start with the rising bubble. This one I'm just going to share my code with you without walking through it step by step, but we have a bubble. I believe all this was already created. All you're doing is a counter pattern with your velocity y, using a negative counter pattern to make it go up. So with velocity, the sign just indicates the direction, and then the value is going to indicate the speed. So this is increasing at a rate of 0.2 pixels per frame. Again, our frame rate is pretty high, so it's going to happen pretty quickly, and it builds and builds and builds, and the faster it goes, the faster it's going to go. All right, for the slow down and reverse, this one is almost identical to what we just saw with the car. We're just going in the opposite direction. So I'm going to do this one quickly. So we're going to have a velocity x of the mouse, and we want to counteract that 20 velocity. So we're going to do a counter pattern to the positive. And I'm going to start out with a 1 and see what that does. And that's pretty good, so I'm going to leave it at that. So we just have it's moving from right to left. We do a counter pattern that slowly is going to get it to a positive velocity. Once it switches from a negative velocity to a positive, you see the mouse change directions. All right, just to show it one more time. Oh, well, go ahead and continue. All right, the floating balloon. All right, this says the balloon falls to the ground. Let's change it so that the balloon slows down before reaching the ground and then reverses direction to float away, similar to the image to the right. All right, so this is essentially what we did with the car and the mouse. We're just doing it on the y-axis now versus the x. So right now it is just falling at a rate of 8 pixels per frame. So we want to slow that down. So let's do that first. So we need All right, that velocity of 8, we want to do it next to the balloon dot velocity, and I'm going to do a minus. And I just made a mistake, so there we go. It is a velocity y, so make sure that's the most common mistake here is making sure you use the correct velocity direction, x or y. It's going to be another velocity y. And let's do minus 0.5, and let's see what that looks like. Okay, so that's slowing it down too much. Let's go to a 0.2. Okay, that has it go down and almost come up. I may even go a little bit further to a 0.15. And that one is probably more like the image to the right. So there's really nothing else to do to like reverse it. So it slows down and then it floats back up. Okay. All right, so that finishes the practice problems. Alrighty, our assessment. We have a rock. It says the rock is thrown in the air, but it never falls back down. Add code to make the rock slow down and then fall. Try different numbers in your counter pattern to see what you like best. So we have a rock that is thrown up, and we want gravity to take its toll and make the rock come back down. So again, we have a rock that gets an initial y velocity of -10. So remember, with the y's, the negative makes you go up, and it is going at 10 pixels per frame. We also have a rotation speed that gives it a rotation to make it a little bit more realistic, which is kind of cool. So the counter pattern we're going to do with the y is going to be a positive counter pattern to combat that negative velocity to eventually get it to 0 and then make it change direction and fall. So it looks like 0.2 is what kind of seemed to work there. So again, we watch it almost gets to the top and then it falls, and as it falls, it gains speed just like it would with real gravity. Okay, challenge problems. The curve has been around for a while. I am going to share my code on this one and kind of explain it, but I'm not going to reinvent the wheel because this one does take a little bit of trial and error. So just for time's sake, just kind of running through, we have a plain sprite, we have a rock sprite, and then we have a rock down. So that kind of gives us this little cavernous looking thing. The plain velocity y, I cannot remember what it was initially, but I wound up having it at a -9. The velocity x is at a 3. So what that means is it is going up initially at 9 pixels per frame, and it's moving to the right at 3. All right, so what we want to do is inside our loop is we want to figure out a way to kind of combat that rising to make it go down enough to kind of get through. So again, the 0.2 seemed to be the one that got the trick. Obviously, if you wanted the super extra challenge, you could try to make it so that once it gets to a certain point, it then just goes straight, but we're not going to do that because that's not required. All right, so that is the first challenge. Okay. B is a deceleration. You need to make the car slow to a halt before it gets past the top of the screen. So again, we've seen similar, a lot of these are very similar. So it's got a negative y velocity, and we want it to make the car completely stop. So first we need to slow it down. So we are going to say car, I'm assuming is the name of the sprite. Yeah. So it's going to get, and we're going to do a plus, because remember our y's is going negative. We want it to go positive. So it's going to get a car velocity y. And I'm again going to do plus 0. Let's do a 0.3 and just kind of see where it stops. So that's, I need to go up a little bit more. Let me try 0.4. Okay, that gets it pretty close. And then I'm going to do like I did with the other car one going towards the lake. I'm just going to say if, and I am going to do a less than. I'm going to say if, actually, I need to do, a greater than. That one almost got me. I'll do a greater than or equal to. So if car dot velocity y is greater than or equal to 0, then we want to set the velocity y at 0, and that will make it stop moving. There we go. Okay, so it's a couple of lines of code right here and right there. Okay, those are 2 of the challenges. All right, again, for my class, I typically just require 2 challenges. I'll go ahead and do the jumping alien just in case anybody tried that one. I do let you pick. So right now, nothing is happening. All right, so this one we want to be mindful of the alien not falling through the ground. But this one's our directions. I'm going to have to collapse my toolbox for a second. I use the counter pattern to bring the alien down when it reaches the top of the screen, when the space bar is pressed. So here is, so when the space bar is pressed, so we're going to go to if, and then in our world menu, we should have a key went down. That'll be the space bar. Then we're going to set the name of our, I'm assuming it's alien, yes. And that is just a y. I want a velocity y. Alien velocity y is going to be a negative, let's do a negative, not 45, -5. Let's reset and run. And that has our alien go up, but we want him to come back down. All right, use the counter pattern with the velocity to bring the alien down when it reaches the top of the screen. Set the alien's velocity and reset it starting y location to make it land on the ground. Alrighty, so it looks like it use the counter pattern to bring it down. So we're going to have alien velocity y. So that is a negative, so we're going to do a positive counter pattern. Alien dot velocity y plus 0.1. Okay. And that probably needs to be inside the loop, does it not? Up, so we are not. Oh me, so how do we want this to? All right, so if it's only gonna jump there, then we I wish I could read those a little bit better, so this, well, they're not we're supposed to. This will be the easiest way. Let's just say we're going to let our alien get to about 100, and then we'll say if alien So where does our alien start? All right, it's at 310. Let's see if it gets less. And let's start out with 200. So kind of let it go for a second. All right, let's try that. Okay, so I'm going to change it to 250. That was a little bit too high of a jump. All right, that one will work. And then that is us using the counter pattern. And then to make it reset and land, we will have another condition that if alien dot velocity y is greater than or equal to 0, then we're going to set that to 0. So we put our space. Alrighty. And I just realized it is the end of the day and my brain is not firing, so it can't be the speed. So I don't know why I did a velocity. It should just be a y position. That's greater than or equal to, what was it, 310, I think. So let's try that. Okay. And we are probably, where did it start? 310. Let's do this. And now it magically works. So they kind of set us up for failure on this one. Typically, you're kind of checking stop a jump needs to be first. So if you go in this order, it's not going to work. So that should be our final piece. So again, we can press a space bar, we go up, and then we start to fall, and then we stop back. So we have to have that, if the alien's y is greater than or equal to 310, it'll set the velocity to 0, but that needs to come first. Otherwise, if it's down here, it's going to prevent the space bar from working. Okay, so I think that is enough for this lesson. If anybody needs help, or if you tried one of the other challenges and need to see a solution, let me know. I can make a quick video for that. Otherwise, that finishes lesson 22.